When we divided and the remainder was 0, okay, like if I said, hey, what's 18 divided by 6? 3, and there's no leftover. Agreed? So what that means is we call 6 a factor of 18 then. Agreed? Yeah. Okay. But let's say I did 18 divided by 5. 5 would go into 18 3 times and then a remainder of 3, correct? So is 5 a factor of 18? No. And so we know things about factors, but that's really why. It's related to the remainder. For numbers, when we get a remainder of 0, we call 5 a factor of 20. I said when 20 is divided by 5. The answer 4 is also a factor of 20, because when we do 20 divided by 4, we got 5. Okay, so those two things are factors. Well, the same thing actually is true then in polynomials. So I used k the other day, but we'll use c. C is just a general number. Okay, we don't know what it is. It's going to be a number in a second, like a real number. If we divide and we get a remainder of 0, what that means is x minus c is a factor of the polynomial. And so what we can do then, because I hope your teacher told you this in Algebra 1, I know one of your teachers did, when you factor something, really what you're doing is you're dividing. Because factoring is reversing multiplication. So I don't know if you guys remember this from algebra, but when we factored things like this, let's see, what I always told students to do, what does this factor into? X plus 6, x plus 1. What I always told my students to do is, if you're not sure, multiply to check, because really what I'm doing is I'm reversing the process. All right, so relating factors to zeros. We also need to understand how factors of the function are related to its zero. For example, consider this function, x squared plus 7x plus 10. You agree that it factors into x plus 5 and x plus 2? So we just learned that what would be then the zeros of the function? -5 and -2. So then we would know those zeros. Furthermore, on the graph, what does that tell us? If I said, hey, would you sketch a graph of this then? Well, first of all, we know it's a parabola opening up. But what else do we know? It crosses the x-axis at -5 and -2. Okay, and so factors, zeros, those things are related to each other, and they're related to the graph. Okay, so I think I gave you this earlier. For a polynomial function, x equals c is a zero of the function if and only if x minus c is a factor of the function. All right, so here's the deal. Let's summarize all the things. If we know that this is a solution, by the way, you might see this word root. The word root, 0, x-intercept, those are all interchangeable. They mean the same thing. X equals c is a solution or root of the equation f of x equals 0. Then, when f of x is divided by x minus c, the remainder will equal 0. All these things are true. C is a zero of the function, c is an x-intercept of the graph, and x minus c is a factor. And so we got to kind of keep track today of all of those things. Okay, so we're going to refer to this list. So let's try it. Let's say the only thing I told you was 5 is a zero of f of x. Can you tell me then 4 equivalent statements that you know are true? Somebody tell me one. Good. X minus 5 is a factor of f of x. Very nice. What else? So it is 0. I'm telling you that. You got to tell me another thing. Tell me another one. How about on the graph?
It's an x-intercept.
Good. 5 is an x-intercept. when f of x is divided by x minus 5, the remainder is 0. And then the last one would be x equals 5 is a solution to f of x equals 0. And guys, this is just a fancy way of saying f of 5, if you plugged 5 in, you would get a 0. So if you'd rather state it that way, if that makes more sense to you than stating it that way, that's what that really means. So why in the world did I make you do division yesterday if this is what we're talking about? That's what math's about. Just because I wanted you to do polynomial division. Because now, Aiden, this is going to answer your question. Now I can factor this using my knowledge of this. Okay, and so here's what we're going to do. We are going to look at the graph. You're not going to get it out in your graphing calculator. You're going to look at this graph. Let's assume the scale is 1, so each tick mark is a 1 on the x-axis. And we're going to assume that this crosses here and this crosses here. And I'm not so sure about that, but we'll figure out what it is. Okay, so do you see that there's 3 zeros? So we can agree that there would have to be 3 factors. The reason they're called linear factors is x has a degree of 1, and when x has a degree of 1, that's linear. So that's what that term linear means. So we are going to, and I don't care where we start, we are going to divide off the zeros. So I'm going to start by saying this. I know that this factors into x plus 2, x minus 1, and something else. Agreed? Just from looking at the graph? Are we okay with that? All right. Let's figure out what that something else is. Where do you want to start? You want to start with this one, so 2? All right, guys, let's put negative 2 in the box. We're going to divide it off and see what happens. And we're dividing this function f of x. Are you getting what I got too? Okay. So I just took this and divided by this, an x cubed divided by an x. What this means is it factors into x plus 2 times 3x squared minus 2x minus 1. So I'm partially factored now. Okay, but this is a linear and a quadratic. Okay. So if you're really good at factoring, do we know how to factor quadratics? Yes. Or if you're not so good at factoring, what you can do is use synthetic division again, and that's what I'm going to do. Okay. So we know it's x plus 2, and then we know this factors into 2 more things. Do I know one of the factors? Yes, one of them has to be x minus 1. So what I'm going to do now is I'm going to use synthetic division. I'm going to put 1 in the box. And I'm not going to use the original. I'm going to use 3x squared minus 2x minus 1 because I want to factor that now. Because the factor is x minus 1. So this is where it starts to get a little tricky. So what you put in the box is the opposite of the factor, but isn't it the same as the 0? Yeah, okay. That's because so far I was only giving you these things, and then you were putting the opposite in the back. Okay. Now I just took an x squared and I divided by an x. So shouldn't this just be then 3x plus 1? That's what this means. Okay, so let's put it all together. The factorization is x plus 2. We knew it was x minus 1. And what's the last factor? 3x plus 1. So this is the complete factorization. What if I had a 4th degree? Keep going. You could keep going. Okay, good. I know you did do this before. Cal.
So for that last 0,
Uh-huh.
in the middle of that we want
Thanks, Joe. We should talk about that. If you set 3x plus 1 equal to 0 and solved, wouldn't we get negative 1/3? So this 0 right here is negative 1/3 0.